Okay, my friends. So homework is out. A few things. I sent an email home to all parents, not because anyone's in trouble. I sent an email home to all parents, just explaining that this content in Algebra 2 right now is the toughest math that you will see ever, and it's just the nature of the beast. Of what it is. And it's not because anything's wrong with you. It's not anything wrong with the class. It's just, this is like the first thing that you've had to take 4 or 5 different pieces of prior knowledge and put it together. You've had to take the prior knowledge of how to add and subtract and multiply and divide fractions. You've had to, bless you, you've had to take the prior knowledge of how do you do an exponent. And then we gave you the new knowledge of I'm going to change a radical into an exponent, or I'm going to change an exponent back into a radical. And now we're going to raise things to fractions, which is just like the devil in disguise. So this morning I had a total of 12 students so far that have come in early to meet with me, not to say I want to drop the class, going, you really, I mean, if you're sitting at home and you're staring at it and it's like, all of a sudden it's like ants crawling around on a piece of paper, close it, come see me in the morning. I'm serious. I'm not saying that. I'm not trying to take away from you doing homework at home. I'm just trying to say, hey, there's a lot of stuff in this chapter that is tough, okay? And it's tough because it doesn't work how your mind thinks that math should be progressive. And there's nothing wrong with your mind. It's just we're getting a little bit further with what math content is. And I promise you, the better you do with this stuff, if you can get through this stuff, calculus is a piece of cake. I promise you. Okay? If I can make it through calculus in 7 years, y'all can make it through it. All right, so let's take a look at worksheet 8C. Let's talk about what kind of questions did you have on the front page? Yeah, because you didn't try. 20. Okay, so problem number 20. First thing I want to take a look at is I'm going to look at the denominator first. Now, I'm going to go through the same kind of process of thought processes. Not everyone will always work on the exact same. The very bottom, is there a third root of 8? It's 2. Is there a third root of x to the third? Yes. So what is the denominator without doing anything fancy with math? 2x. And again, please, by all means, use this as notes on your homework as well. You're here, I'm giving you the points for the homework. If you're not here, you got to turn in the homework. Okay, so that's my first step. Now, next step. Can I break 25 up? And that's just a square root on top, right? So can I break 25 or 75 up into 25 and 2? 20. All right. All right. So 75 breaks up to 25 times 3, yes? Guys and girls, if you want to sit here and talk the whole period, sit in the hall, please. You're not in any trouble. Just get out of the class and sit in the hall. This stuff is too tough for me to say, I'm going to sit here and talk, or I'm going to meet with my tutor. If you're going to meet with your tutor, just leave. Seriously. Let me get you through it. All right, so what's the square root of 25? 5. Can anything else come out? Can this come out or this come out? No. And then our very last step is say, hey, does 5 and 2 reduce? No. Can I reduce the x's? No. Yeah, go. I don't have it. Okay, let's move on to the next one. What else do we have on the front page that we want to take a look at? Yeah. 10? Problem number 10. So I get 5 over 15 square root of x squared over square root of 24. Did I write that down right? Okay, now, first step on this problem, it looks like it's a lot tougher than it should be, but can we feel okay about this? Do I have both square roots on top and bottom? One's not like a third root or a fourth root, and the other one's a different root. So they're the same root top and bottom? Okay, so that means that 24 goes into 48 twice. And what's the square root of x squared? X. So I get an x root 2 on top over a 3 on bottom. That's it. What else do we have on that front page? Yeah? 19.
Wasn't it only evens?
Yeah.
Oh yeah, it's just evens, I'm sorry. It was evens only. Yeah. 8? Yeah, it was evens only last night. Problem number 8. So now are you figuring out, uh-oh. So some of you might have gotten really good at this. Okay. I have 2 different square roots, agreed? I don't think I should go about doing this problem going 56 times 21 and then breaking it down to perfect squares. Is that okay for me to say that?
Yeah.
So outside right now, I am totally content that I'm getting a 6 on the outside. Is anyone stuck on that?
No.
So then, let me think about 21. 21 is the same thing as 3 times 7. And the reason I put it over there is to be under that 21. So is there any way that I can make 56 either 3 times some number or 7 times some number? 7 times 8, good. So 56 is 7 times 8. Can 8 be broken down into any perfect squares? 4 and 2, right? So I have this whole string of things I can multiply together to get whatever, excuse me. If I multiply 7 and 4 and 2 and 3 and 7 together, that's the same thing as 56 times 21. Is that okay? How many of a kind am I looking for? 2 of a kinds. Okay? So I have a pair of 7s here and here. So what's the square root of 7 and 7? 7. So there's a 7 outside, joins the 6. Is that okay? Do I have any other perfect squares in there? 4. What's the square root of 4? 2 times 2. And then I'm left with 2 times 3, which is 6. Almost done with the problem. Almost done with the problem. So I'm going to go 6 times 7 is 42. 42 times 2 is 84. Root 6. And we're all done. Yeah. 18. Okay. 18. Fourth root, that's a good one. Fourth root of 1 over 3. So do you feel comfortable if I were to say, hey, the fourth root of 1 on top is just 1? Is that okay? That's kind of a nice little thing, but you're like, I don't know what it's going to do to help me, but it's going to help me, I hope. Okay. So does that seem like an okay move so far? How many of a kind am I looking for under a radical?
4.
I'm looking for 4 of a kind because it's a fourth root, right? How many more 3's do I need to add or to multiply times this to get this to be a perfect fourth? 3 more. So 3 times 3 times 3 is 27. Agreed? So I'm going to multiply both top and bottom by the fourth root of 27. Okay, the fourth root of 27 over the fourth root of 27 is the exact same thing. That's just like me saying 1. So that means on top, I'm going to get the fourth root of 27. Fourth root fourth root of 27 on top. And then on bottom, that's going to be 3 times 27, which is 81. What's the fourth root of 81? 3. Done. One more from the front. Yeah.
So about this question, the 27, what is that?
Okay, so if I wanted a perfect fourth root underneath, I'd need this. So the fourth root, I'm looking for 4 of a kinds. Well, I have one of them. I need 3 more because 3 times 3 times 3 is 27. Is that okay? One more from the front. Good? 16. 16. X over root x, or third root. Did I write that down right? Okay. I'm looking for 3 of a kinds on bottom. So what should I multiply both top and bottom by in order to get 3 of x's on the bottom? Okay, so I'm going to multiply by the third root of x squared, both top and bottom. Is that okay? So on top, I'm winding up with x, third root of x squared. Is that okay? How many x's are now on bottom? 3. So it's x to the third. So what's the third root of x to the third? X. Do I have an x outside and an x outside? Yeah. Cancel them. Third root of x. Third root of x squared. That's it. Backside. Let's take a look. What do we got? Go ahead. 2, 2. You got it. Okay, so we're multiplying things together, which is fine. So far, I feel comfortable that there's going to be a 3 out in front. Is that okay? And not a 3 out in front because this is the third root. It's because I have that 3 over there. Let's do this. I want to start thinking about perfect cubes and see if we can start doing some of that. So we all know 1's a perfect cube. We know 8's a perfect cube. 27's a perfect cube. 81's a perfect, no. 27, 64 is a perfect cube. 125 is a perfect cube. And if I see 125 as a perfect cube, that's going to give me, take care of that right there. Is that okay? And then I'm going to combine my x's together underneath. Is that okay? And then I still have that 4 right here. So that 4 is 2 times 2. And then I have y to the third. Can everyone see where all the numbers came from? All the exponents. Okay, so that 3's up front automatically. What's the third root of 125? 5. I have 3 of those, so what's the cube root of that? 2. This is all outside. And then I have x to the 6th. Is x to the 6th a perfect cube? Now, before you're like, I'm not sure, does 3 go into 6 evenly? Yes, so what is the cube root of x to the 6th? X squared. Good. What is the cube root of y to the third? Okay, so now let's take a look. 3 times 5 times 2, that's 15. 2, I get 30. X squared, y. I don't have anything under the radical left. Huh. What else do we got? Yeah.
26.
26. Okay, so third root. So let's knock the obvious out. Can I do the third root of 8 on top real easy? Yeah. And I just get 2? Is that okay so far? All right. Does 3 go into 4 evenly? No. So how many more x's do I need to add to that before it goes in evenly? 2 more, right? Right? So if I multiply both top and bottom by x squared, and it's the third root of x squared, that means on bottom, I'm going to have the third root of x to the 6th. So what is the third root of x to the 6th? Squared. Good. So my bottom of this is going to be just x squared. And then on top, I'm left with 2 third root of x squared. I cannot reduce, since being that's inside the radical and that's outside, I can't reduce those. Here's my answer. What else? Yeah?
36.
36. 36. Okay, so I'm looking for 5 of a kinds now. Ay, ay, ay. Okay. I can't keep a radical on bottom. If I'm looking, how many 3's do I have on bottom? 2. So how many more do I need to get a 5 of a kind? So I'm going to multiply both top and bottom by the 5th root. So I'm going to go 3 to the 3rd. Is this a perfect cube? Yeah, because 5 goes into it evenly. And this is actually a perfect, or 5th quintet is what it's called. Because 5 goes into 10. All right, so, right? Did I say that right?
It's like 4 squared.
Is that 4 to the 10th? Okay, yeah. So 5 goes into 10 twice, so 4, the 5th root of this is equal to 4 squared, which is 16. Is that okay? The reason that works is because if I put this back in exponent form, then I get that makes sense? Okay. So I know I have 16 on top. I'm good with that. I'm not even going to mess with anything. I swear to God, I have no idea why is there slamming of doors? It's like, dude, sit down in your chair, wait 27 minutes, and be done with school. I'm so hyper though. Okay. So I'm multiplying the bottom by 3 to the 3rd. I have to multiply the top by 3 to the 3rd. So I still have the 5th root of 3 to the 3rd that would have been on top. On bottom, this is going to be the 5th root of 3 to the 5th, which is just 3 on bottom, over x to the 3rd. Check to see if I can reduce 16 and 3. Nope. We're done. Hold on to those. Hold on to those. You were here. I'll give you points for it. I have notes someplace. Okay, and this is just building on what we've been working on. So it's not like I'm giving you like, dude, we're changing gears again. This doesn't mean I'm stopping collecting homework, or you can just give up on doing it, because unfortunately that might be a bad choice. Okay, so we're still simplifying radicals. Ta-da, yay. All right. Move that out of the way, move that out of the way, and move that out of the way. Okay. So rational exponents represent roots. The things that I just moved out of the way are already on your thing, so Can we get on notes? You got extras? You got notes? Extras? You got it? Girls good back over there? Yeah. I've been doing better. Alright. Alright. So things to remember, multiplying fractions and dividing fractions, all of the fraction rules are all engaged. Let's deal with this. Alright. So first problem up here. It kind of looks awkward, but we have to recognize that I have 16 to the 1/3 power, and I have 16 to the 1/6 power. Is that okay? That seems pretty happy right now. So I'm going to deal with something with 16 in a moment. But first thing I want to do is let's go ahead, like basis, I'm going to add the fractions. If you're not good at adding fractions, my fancy way works pretty well. So you get 6 plus 3 over 18. That's 9 over 18, which is 1/2. So then I wind up with 16 to the 1/2 power. Is that okay? What's the 1/2 power? Square root. What's the square root of 16? 4. Is that all right? So are they all going to work that way? No. Okay, number 2. The bases aren't the same. Agreed? So I want to make 9 to be in base 3 form. So what this means is there's some way that I can represent 9 that I have 3 raised to an exponent. That's the same thing as 9. 3 raised to the second. So if I change this to 3 to the second raised to the 5/4, so that's going to give me 10 over 4. 10 over 4 reduces to 5 over 2. Is that okay? That's just the top. And then that's just over this. So tug of war between the top and bottom just means I'm subtracting fractions. So I'm going to go 5 over 2 minus 3 over 4. Is that okay? That's what my exponent is going to be. I'm still going to have a base of 3 for right now. So I have 3 raised to whatever this answer is. That's 20 minus 6 over 8, which is equal to 14 over 8. 14 over 8 reduces to 7 over 4. Done. It's not too bad, is it? Can I move on? All right. So being I changed the base on the last one, how can I change the base of 25 to be in base 5? 5 squared. So that means I'm going to have 5 to the 1/3 times 5 to the 2/3. Is that okay? Because 5 squared, so 2 times 1/3 is 2/3. So now I have like bases. What do I do with the exponents? Add them. So 1/3 plus 2/3 is 3/3, which is 1. So my answer is 5 to the first, which is just 5. Okay. So there's a couple ways I can approach number 4. Is 27 a perfect square? No. It does have a perfect square in it, like 9 and 3, but that would still give me a radical on bottom. Agree? So is there a number I can multiply times 27 that would make 27 a perfect square?
Another 3.
If I what?
Another 3.
Another 3. Another 27, you're totally right.
Well, that'll probably be a bit more.
It would be a really, really big number, but if I do another 3, it's going to be an 81. Does that make sense?
Yeah.
So your thought process is perfect, but tone it back a smidge, okay? So I'm going to multiply this by the 3rd root of 3, and on top by the 3rd root of 3, okay? So on bottom, I'm getting 81. What's the square root of 81? 9. Now I'm going to run into a little kicker here. So I'm going to make this 3 to the 5/3. Change that. And what do I change this to? 3 to the 3rd. Very good. Is that okay?
Yes.
So like bases that are being multiplied together, what do I do with the exponents?
You add them.
I add them So I get 6 over 3, which is 2. 3 squared is 9. 9 over 9 is? Didn't see that one coming. Yeah.
So I have 2 questions. So on 3, couldn't you just do 5 times 25 and then just cube root it? Because if you know 125 to the root to the cube is 125, then it would just be 5.
That's another way.
And then for 4, you don't need to do like the fractions because you're just adding another 3, so then it's 3 squared.
Oh, okay. So, but you're still converting. I would have to make
It would
27.
still be 1/3, but
You're right. You're right. That's perfect.
just
That's awesome.
3, 3, 3, 3, 3.
So I see what you're saying. So you're getting them into like bases and then dealing with the exponents. Is that what you're seeing it as?
Yeah.
Perfect. That's a great way of thinking of it as well. Like, yeah.
For 4, for the 3 to the 1/3, like how did you get that? Like the 1/3? Because you just have the 3 in the radical.
Wait a minute. You might be right. Hang on. Did I make an error here? Is that supposed to be 1/2? I made an error on this one. That should be 1/2 power. That should be 1/2 power right there. I'm so sorry. Oh man, I thought that was just gonna work out so nicely. All right. So now, let's take care of the top first. So 5 over 3 plus 1/2. That's 10 plus 3 over 6, which is 13 over 6. Okay, so that gives me 3 to the 13 over 6 over 3 squared. Then I can go 13 over 6 minus 2, which is the same thing as 6. So that's 12 over 6. That's 1/2. So I get 3 to the 1/2 power for this answer. I made a mistake. I'm sorry.
Mr. Stark?
Yeah.
Could you just run over how you combine those fractions with 1/2?
On number 4?
Yeah, just like how do you get from 5/3 and 1/2 to 1/2?
So I'm just adding those. So if I add those together, I get this. 5/3 plus 1/2 is 13 over 6.
Are you like?
Like you seem to have like a trick that like you just like mush it.
So
Like,
yeah,
why?
if you a way of adding fractions, which unfortunately they don't teach you, they call it the butterfly method. Oops, make that a D. It's A times D plus B times C over B times D. And it works every time. If it's subtraction, you just put the subtraction sign right there. And it works every time. So it's this. It's crisscross and then the bottom multiplied. It'll work every time. Unfortunately, we don't teach fractions that way. I don't know why. It's a very quick. I guarantee if they taught fractions this way, every kid would come up through high school going, dude, fractions are easy. But we don't. Yeah. Wait, what? Is it 1/6? Is that 1/6?
Yeah, it's not 1/6.
My gosh.
Yeah, why would it be 1/10?
Sorry about that. Is that the question? Question
Yeah,
there?
I just don't know where you got 1/2.
Are you good with 1/6 then?
Yeah.
Okay, I'm sorry. Because I can't do math anymore. I had 2 periods of Algebra 1 prior to this class and they made me dumb. Alright. Stating restrictions, that should be not equal to 0. That's just telling us we don't have a denominator of 0. Alright. I'm just kidding. Algebra 1's fine. I can't have a radical in the denominator. How many more x's I need downstairs? 1. So I have to multiply that on top and bottom. So I'm going to get 6 third root of x over x. Done. Alright, rather than panicking on number 6, so a few things to think about. Here. Can I move the y up? So that becomes y2, y to the half,
Wait, what?
because it's a negative exponent, so it moves up. Does anything else move up or down?
No.
No. So now we have to start doing tug of war. So tug of war between the x's. I have 7/3 minus 1, which is 3/3. Agree? So that gives me 4/3. So I get x to the 4/3 on top. Tug of war, or move that up, and so I'm going to add 2 and 1/2 together. So that's going to be 4/2. So that's 5/2. So I get y to the 5/2 on top, and are done. Is the anxiety coming up a little bit?
Yes.
Good.
These are easy, and then the homework.
Even with all my math errors up here, it's easy.
It's easier, and I can do it in class, but like homework.
So you might be a good candidate for the next couple of days to start coming in before school and seeing me. There's nothing wrong with you, trust me. All right. I did what? Oh.
I'm just letting her life.
Why not before school?
Because I have problems.
No,
it's like my sister drives me.
Your sister what?
Drives me to school and she won't leave early.
Yeah, that's kind. So do this. You got to be this sister now. Hey mom, there's an email that was sent to you from my teacher when I'm available to help. And before school, every day is there, and period 1, 2, 4, and 7 are there. So if we match up on any of those, perfect. And then if sister's like, I'm not getting up that early, it's like, Mom, this is when I need to get help. Yes, I have second off.
Okay, I have second off.
Great.
Oh my
Woo!
God, great. Yay, it worked.
Now, what's the excuse now going to be because you can't make it second?
I don't have one.
You don't have an excuse?
No, I got it. I'll do it.
All right, we resolved it.
So, can I come in during second?
Absolutely.
Yes.
Everyone else schedule nightmares work out okay? All right. All right, let's before I start realizing I have a perfect square on bottom, which is fine. How do I make z a perfect square? How many more z's need to take place? 1. So I'm going to multiply both top and bottom by z and z. Is that okay?
Okay.
So on bottom right now, I'm just going to get 6z. Yeah, that's what I wanted to happen. 6z. All right. Ready? Is 8 the same thing as 4 times 2? So the square root of 4 is 2. Is that okay? I still have a 2 inside, right? I just put that so I know it's there. How many? I have x to the 3rd, so that's x squared x. So I have an x outside, and one of the x's is left still inside. Is that okay? Is y squared a perfect square? Yep. So that comes out. And then I have the z that's still left inside. So inside my radical, I have a 2x and a z. And then we need to take a look. 2 and 6 reduce. I have a z inside, z outside. Nothing good happens with those guys. 2x z over 3z. Does it work? Check out. Tug of war with these, which means we're just going to subtract fractions. Good with that? So going with my way. Ready? Ready with my new way? We good so far with how that's set up? 2 times 5, 10. Still with me? Minus, still with me? 3 times 3, 9. Over 3 times 5, 15. Which gives me 1 over 15. So I wind up with x to the 1/15th power.
Seriously.
Like you're getting angry. You're like mad at your middle school or elementary school teacher because they didn't. You're like, dude.
So much faster.
Like here, shade in half a circle. Show us a third of a circle. Okay. You guys remember this, right?
I remember that. It sucked.
I know. And then the elementary school teachers, yeah, but it says it in the book. It's like, would you quit buying your own books, write your own books like us, and do it?
I could never draw
Core
a third.
curriculum sucked.
Buy your own book.
I couldn't draw the freaking third. I'm capable, but I'd always accidentally make a peace sign. And then I'd have a weird third, but then one of them would be split.
Yeah,
Then
you
your
had that-
teacher's docking you because you didn't get 25% of it.
Yeah, that
Perfect.
special friend.
Like it's more like 30% you have in there. It's like, yeah, my dad helped me. It's the first time I spent time with my dad in 6 years. I'm sorry. Something's wrong with me. You guys all knew that already.
Hey, let's go get notes.
And we got it's being recorded too. So, all right. Can I finish? We're almost done, I think. All right. Tug of war with the A's. Yes. Who wins? Top or bottom? Top by how much? 3. So I get A to the 3/5. Everyone good with that so far? B is just its own entity. This actually moves down, so I get 3/3 on bottom, right?
C.
So I get C.
A, B, C.
All right. Almost done. Actually, I don't know how much I have left.
Then you add it to
Peanuts.
C.
Okay, ready? If I multiply these together, I get x to the 6. Is that a perfect square? So what do I have on top then? 3x to the third. Awesome. What about on bottom? Is that a perfect square? 4 x to the 4th. So 3 and 4 stay as is. Tug of war, who wins? Top or bottom? Done? We doing all right? We good?
No.
All right. You already have those words there. I'm just going down to the problems. Okay. Like bases. So that's a negative. I have a to the 4th, which is a to the 3rd a. Agreed? So I get an a outside and 1 stays inside. Yes? I have a b to the 3rd root of b to the 3rd. I get b comes out. Is that okay? What stays under there?
1A and a C.
1a and a c. Very good. So that's 3rd root of an a and a c. Is that okay? Notice, are these like terms like that? Be real careful when you're looking at this. Only 5% of you will see if they're like terms. The rest of you will see. No, you have negative AB. That doesn't have a B. Not like terms. They say it. That's your answer. Okay? What? All right. Let's do this. Oh, how many x's do I have? Right there. Huh? 12? What's the 4th root of x to the 12? X to the 3rd times to the negative 3, which is x to the negative 9, which is 1 over x to the 9th. That okay? Getting it? All right. Trying to get like terms. So I have a 4x on this one, because the square root is 16. And I have x to the 4th x. Agree? What's the square root of x to the 4th? X squared. So what's this going to be then outside?
To the 3rd.
To the 3rd. Good. What do I have left inside? X. Agree? We agree so far?
Yes.
All right. Minus 3, and that's an x squared, but I have x squared x inside, so square root of x is x. X comes out, so I get x to the 3rd, and I'm left with this. Are those like terms?
Yeah.
4 minus 3 is 1, so I get x to the 3rd root x. There's my answer. Well, that's a fancy-dancy answer.
I like that. That's easy.
All right, number 13. So third root, we're looking at third root. So I'm going to make 32 8 times 4.
Yeah.
Is that right? And then I'm going to make that x to the 6 x. Is that, if I multiply those together, do I get that x to the 7?
Yeah.
All right, so let's figure out what we have outside. Third root of 8. 2. Third root of x to the 6th.
X squared.
X squared. I have the y squared already out there. What do I have left inside?
4x.
4x. Is that okay so far? Ooh. Okay, third root, 50, let's see. Perfect squares or perfect cubes. We have 1, we have 8, we have 27. Ooh, 27 works.
Yeah.
So I'm going to go negative 27 times 4. That's the same thing as negative 108. Agreed?
Yeah.
Y to the 6 is going to come out nicely because it's third root. And then I'm going to change that to x to the third x. Okay. So on this problem, I have plus. The third root of negative 27 is negative 3. Agreed? I have an x out there, but something else is going to join it. So let's see. And x, bless you. This x, third root of x to the third, that comes out, so that's x squared.
Y squared.
Then let's see. Third root of y to the 6th is y squared. Oh shoot! That just get away. We need nice things.
You can't
Nice
just tell
thing.
them to get away.
Dude.
There's like an arrow
No, that's a pen.
next to the circle.
Pin.
Like where the circle is, there's like
Top right of the wheel. Oh, okay.
but there was like
Stay there. All right.
Give that to the video.
Shoot! I just lost train of thought. Third root of 4x.
She gave me the Lego Lego.
All right. Like terms all the way across, so I'm going to get negative x squared, y squared. Third root of 4x. Done.
Who's calling?
So you had 2, 3 root 4x.
Okay.
Why is it not like 2?
Wait, you asked me something and I don't know where I was at.
So there's like 2 different ones that are 3 root 4x. Why are they like why is there only one in this?
Because I added them together.
So then how does that make how is that not?
Here, look right here.
it is different.
X squared, y squared, y squared. Third root of 4x, third root of 4x. Complete like terms. So then I'm just going to go 2 minus 3 is negative 1. X squared, y squared, third root of 4x. All right.
Okay,
All right, where are we at?
Can we
That's
not?
the last one.
That was the last one?
Wait, no, it wasn't.
Can we not? No.
Wait, is there homework?
Do you guys want that one? Or are you done?
Done.
All right, 8D even. Worksheet 8D even. Yay! Guys and girls, promise me this. Promise me this. That you will not be sitting at home staring at ants crawling on a page if you don't get it. Put it away and just come find me Monday.
What time?
6 o'clock in the morning.
What time Monday morning? I get here at 5:45. So from then on.
Get there at 5:15.
I'll get